The physics tutorial. My name is Momo Kenie. We continue to look at the physics past questions on elasticity. Now, the other question we want to look at was a question that came in 2004. It reads, a sphere spring of natural length. When we say natural length, is the original length. Nothing has been attached to that particular spring. So the natural length is 20.00 centimeters when there was nothing attached. Has a scale pan hanging freely at its lower end. Let us put highlights here for simple analysis solution. Let us say this one is a spring, but there is a scale pan at the lower end. According to them, that is what they are saying. There is a scale pan at the lower end. This is a spring. The spring is suspended, and there is a scale pan at the lower end. According to them, the length of this spring is 20.00 centimeters. So from here to where the pan is 20.00 centimeters. And the mass of this pan, we don't know. We can call the mass of this pan M. That M is the mass of the pan. Just like if you attach a particular pan to an object, you don't know the mass of that pan. So you can call the mass of that pan M. M represents the mass of the pan. We go to the second sentence. When an object of mass 40 grams is placed in the pan, the moment somebody place an object now of 40 grams in this pan, the length of this thing will extend, will go down. Have in mind it's a spring. The more you attach, the more the object, like this, if this is the original length, the moment I load, the more the length increases. So if somebody now places a mass of 40 grams in this pan, you are going to get it in this form. It will extend further down. That is what you get. So when it extends further down, the mass now that is here is causing an extension. It's placed in the pan, its length becomes 21.80. So the length now becomes 21.80. That means it will be longer than this one. And the mass inside here becomes M plus 40. Have in mind, the pan itself, the scale pan is M. The object again is 40. So the total mass now will be the mass of the pan and the object in it. So if that is the case, it becomes M plus 40. We'll go to the other statement. When the object is replaced, when they now replace this object, the moment you remove this object, the thing will go to the original length again. Now it was replaced with another mass of 60 grams. When you put another mass in this thing, 60 grams, it will come below the 40 because 60 is greater than that. You get something like this. And here it now becomes M plus 60. Because the pan itself is M, the mass is 60. It becomes that. And the overall length here is 22.05 meters. So if that is the case, we can get the extension here. Where the original length is 20.00, you attached a mass of 40 grams, the whole length now became 21.80. So what was added to this? For you to get what was added to 20 before they got this figure, it becomes 28.80 minus this one. 21.80 minus 20.00. That becomes 1.8. That means the moment they added a mass of 40 grams here, the extension they got was 1.8. When you come here, something that was originally 20, it was originally 20 centimeters. When they now placed a mass of 60 grams in it, the length became 22.05. So the extension there, what was added to this 20 before they got 22.50 is the same as 22.50 minus the original length. So the final length minus the original length is extension. What you have at the final point minus what you have initially. We tell you what was added. So we have 22.05 minus the original length here, which is 20. That is giving us 2.05 as extension here. Now we progress. We now want to get the mass of the scale pan. How are you going to get the mass of the scale pan? The mass of the scale pan can be calculated in simple form. We already know that the formula for force is mass times gravity. The formula for the force is the mass times the gravity. Mass times gravity. Close that back. F, we know F, the force is mass times gravity. But again, we know very well that F again is given by Ke. From Hooke's law, the force is directly proportional to the extension. Hooke's law will give you that. So wherever we see F, we put mg. F is here, we put mg. Because the formula for force is mass times gravity. Mg equals Ke. If that is the case, the mass in the first case, the mass here is m plus 40. The total mass in the first case is m plus 40. That means the pan and the 40 that was placed. So the mass here, the m you see is the mass. And that mass in the first case is m plus 40 times the gravity. The gravity G equals Ke. We don't know K. E, we know the extension. The extension at that point is 1.8. So we have times 1.8 here. We can call this equation 1. We go to the other diagram. We still make use of mg equals Ke. Mg equals Ke. But when you are here, the mass under this diagram is m plus 60. So if that is the case, this m here becomes m plus 60 times the gravity equals K. The extension at this point, we got that as E 2.05 when we subtracted 22.05 minus the original length here. So that gave us 2.05 equals equation 2. Now in general mathematics, when you have an equation with 3 terms but linked with multiplication, you can see multiplication here, you can see multiplication here. We solve that equation using simultaneous equation. It becomes simultaneous equation. And the simultaneous equation method that we use, since we have G here, we have K and K, no difference, we can solve that by dividing one equation by the other. So if that is the case, I can divide equation 1 by equation 2 or equation 2 by equation 1. If I divide this equation by this equation, the left hand part of this equation is m plus 60 times G. M plus 60 times G. I divide that by the left hand part here, m plus 40 times G equals the right hand part, K times 2.05, divide that by the right hand part of this other one is K times 1.8. The K cancels, the G cancels here. So what we have is m plus 60 divided by m plus 40, given us 2.5 divided by 1.8, 2.5 dividing by 1.8, no, 2.05 divided by 1.8 will give us 1.34. We cross multiply now from that end. If we cross multiply, whatever we have here, we multiply by this. Whatever we have down here, we multiply by this. Here, the value down is 1. 1 times m plus 60 is the same as m plus 60. Equals, we now have 1.34 times m, and 1.34 m. And then we have 40 multiplied by 1.34. 1.34 times 40 will give us 53.6. We collect like terms. We put all the m's together and all the values. We have 60, when this crosses, become minus 53.6 equals 1.34 m. When m goes over there, become minus m. So 60 minus 53.6 is given us 6.4 equals 1.34 minus 1. Have in mind the coefficient here is 1. That becomes 0.34 m. For you to get m, you divide both sides by 0.34. m becomes 6.4 divided by 0.34. So m is given us 6.4 divided by 0.34. That will give us 18.8. 18.8 becomes the mass of the scale pan. The other question, which is also a past question, says a wire of length 55 meters. That is the original length. The original length, you say the original length, symbol for that is L0, according to them is 55 meters, where nothing is attached. Has a force constant, 700 Newton per meter. Force constant is known as K. K is the symbol for force constant. And they said is 700 Newton per meter. Extends to 55.06. Let us look at this diagram this way. Let us call this the original length. When there was nothing attached, L0, the value for that was 55 meters. When something was attached to this one, This thing extends now to, it is now extending to 55.06. So it starts from here now, it is ending here as 55.06. So that means that the small portion that was added to it, you can get that by 55.06 minus this one. Have in mind when you want to get this small portion from here to here, it will be from here to here minus from here to here. The moment you say from here to here minus from here to here, it is this that you get. And this one is representing the extension. So at that point we have 55.06 minus 55. That becomes 0.06. 0.06 meters is the extension. So when you now say the extension here plus 55, you get the whole length here. So the extension E, we now know that the extension E is 0.06 meters. We will now progress. The question says you calculate the work done by the load. The work done by the load is the same as the energy exacted there. So if that is the case, the work done and the energy stored will be the same. Equations we have are F, W, work done equals F, half of Fe, or work done or energy is half Ke square. Now there is no force in the question, but we know the force constant, we know the extension, so we make use of this formula instead of this. Hence, the work done become half the force constant K. This K, according to the question, is 700 here. You have 700 times the extension E is 0.06, but it has a square, so all square. So work done becomes 2 can go here, 1 into 700 is 350 times 0.06 squared, 0.06 all square. That will give us 0.0036. When you multiply that by 350, you multiply that by 350, you are going to get 1.26 joules. Thank you and God bless you.